Hello everyone, let's find out as to what is the force between the plates of a capacitor. To understand this, let's consider two plates of a parallel plate capacitor. Let us call this as plate 1 and then plate 2. If we connect the plate 1 to a battery's positive terminal, then this would be having a positive charge and this would have a negative charge. You learned in high school that like charges will attract each other, because of which there will be a force existing between plates 1 and then plates 2. So they will attract each other. We need to find what this force is. To find the force, let's recall that the electric field exists between the two plates. The field goes from plate 1 to plate 2, and we know that E is equal to minus of dV by dx. It's already been derived. Check it if you don't understand what this is. If we multiply by Q on both sides, then this term here is called as force. So F is equal to minus Q dV by dx. Let's take Q inside. It is equal to minus of d into Q into V, because Q is a constant, by dx. But Q into V is called as potential energy. Therefore, F is equal to minus of du by dx. This is the force for a this is the expression for force for a conservative field. Now in this case, let the distance between the two plates be x. Let the charge on this plate be q. This will be minus q. And let the voltage drop between the two plates be some V. So we learned to what is U. It's already been derived. So I can say U is equal to half into C into V square. It's been already proved. That is half into C. This is a parallel plate capacitor. So C is equal to epsilon naught A by D, and V in terms of E and X would be E is equal to V by X, or V from here is equal to E into X. So it will be E into X, and then since you put X here, we write this also as X. Remember that it's a distance between the two plates. I just call this X in this case. It will be same as X here, whole square. That is equal to half epsilon naught A E square X square by X. So 1x gets cancelled and we get U is equal to half epsilon naught A into E square into X. But what we want is we wanted du by dx first. So find du by dx, that is equal to d by dx of the whole term here, which is half epsilon naught A E square into X. For the given combination of capacitors, half is a constant, epsilon is a constant, A is a constant, and even E is a constant. Therefore, these terms come out of the symbol of differentiation. So what remains is it will be half epsilon naught A E square and d by dx of x, that's equal to 1. Therefore, what we get is we get du by dx is half epsilon naught A into E square. This is what is the value of du by dx. But recall F is equal to minus of du by dx. Therefore, putting it back here, you get the force as minus half epsilon naught A into E square, which is a constant. So this is the required form. Here we find a minus sign. So minus sign indicates it's an attractive force. So wherever the force is attractive, the form would be a minus sign.